Welcome to this OST2 lecture about creating TPM 2.0 policy using TPM2 tools. We will also be giving hints about how to use eSAPI to create a policy when generating new TPM objects. In the previous lecture, we looked at a list of the available TPM 2.0 policy commands. Here, I'm using a very nice diagram of the available TPM 2.0 policy commands by Imran Desai from his talk about TPM 2.0 mutable policy. This diagram allows us to see how the different TPM 2.0 policy commands correspond to different properties of the TPM. For example, TPM2 policy counter timer relates to the reset flag, to the counter of the clock, and this way we can create rules that relate to the state of the TPM. The same is true for policy locality, where we bind the use of a TPM object to the current level of locality. And policy physical presence will not be used very often, since this happens usually at locality 0, but this is actually testing if there is physical presence on the TPM, which is a physical pin, and if voltage has been applied to that pin. This usually takes place when we perform a TPM 2.0 clear, and therefore it is rarely used. However, I very much like this diagram because it shows us how the different TPM 2.0 policy commands relate to different TPM 2.0 properties. For example, policy NV relates to the non-volatile storage of the TPM. We have policy commands that relate to the command response of a TPM command. We can bind a TPM object to the object's name, which we know is a hash of its public area from previous lectures. We also have different policy commands to further harden the secure key generation. And of course, we have the policy PCR command, on which we'll be taking a closer look. This one allows us to bind our TPM object to the state of a PCR hash digest, and that hash digest of course can represent the system state or a property or something else. It gives us a lot of flexibility here. Then we have the policy out value, policy password, and policy secret, which gives us additional set of authentications. And we've seen how this works with the endorsement hierarchy, and we'll take a closer look now. In the previous lecture, we looked at policy password. In this lecture, we'll look at policy secret as a quick example of creating EI policies using TPM2 tools. We already used EC's policy secret to satisfy the EK template in lectures D. Today, we'll try to do the same, but for keys living under the owner hierarchy. We'll look at two different examples. One will be creating a primary key with a similar policy like the EK, meaning that we would need to satisfy using EC's policy secret the knowledge of the owner hierarchy. And then we'll try to do the same for a child key. This gives us the flexibility that if the owner hierarchy password changes, this does not affect this TPM object. We just need a user that can satisfy the knowledge for the owner hierarchy. So this gives us flexibility, and it is a great use case of the power of TPM 2.0 policy and extended authorization. Few hints before we start. Creating the policy digest requires a trial session, and we can do that using eSAPI or using the TPM2 tools. When using the TPM2 tools, we need to provide as a parameter the policy digest using the -L parameter. When using eSAPI to generate keys, the policy digest goes into the out policy field of the public area structure. And if you need to take a quick refresher, I would really recommend taking a look at our lectures D2 for examples of the public area. This is create primary and create then are invoked as usual. Now here is the practical flow for generating a policy secret. We first have to start a TPM session of trial type. Why there is no type specified here in this command because the default type for TPM2 start out session 2 is a trial session. So we don't have to explicitly say it. And of course, once we create our session, we want to store it to a context so we can reuse it later with the TPM2 policy comments of our choice. In this case, that is the TPM2 policy secret. And we are binding the policy secret to the owner hierarchy, which means that whoever uses this policy to generate a TPM object, the user then has to satisfy it by proving knowledge of the authorization of the owner hierarchy. Do not forget to flush the context once we are done generating our policy digest. This is just a summary of the 3 commands that we need to create a policy bound to the authorization of the owner hierarchy. Now that we have created our policy, we can create our TPM object. And because this example is about a child key, we need to first create a primary key. There is a quick refresher in TC1101 lecture D. Now, after we have our primary key, we can move forward and create our child key. The primary creation is simplified because we want to focus on the creation of the child key. As usual, we specify the parent, which is our primary key. Then we have the hash algorithm to be used. We store the public part of the key and the private part of the key, that is an encrypted blob. That's why we can store it outside the TPM. And the very last argument is the most important one in this case. This is the -L, supplying the policy that we created in the previous slide. This means that upon its creation, the policy digest will be populated in the out value of this child key, and any use of it later will require the satisfaction of this policy. So why we don't have to satisfy the policy here when we are loading the child key, when we need to decrypt the blob of the private material of the child key? Well, because we're using our TPM2 primary key to unwrap that encrypted blob. And the primary key, remember, we created in a very simplistic way. There is no additional authorization required. There's no policy. So at this stage here, we can load the key. But when we try to use the key, we would have to satisfy that secret policy here. And this we can do only with the policy session and executing the proper policy commands. This is a summary of the TPM22's commands to generate a child key using a policy. Remember, to load the key, we do not have to satisfy the policy because the policy is applied on the usage of the child key. And our primary key in this example has no special authorization. This is why we will be able to load the key. But when we try to use the child key, we would have to satisfy the policy using a TPM2 policy session. Now, let's take a look at the perhaps more interesting use case where we set the policy to a primary key. We already created our policy from the previous slide. This context here exists as we saved it. So we can just reuse that policy and apply it during the creation of the new object with -L, and of course using create primary. Now, to generate the child key, remember we would need to use the primary key as seed and also for wrapping and encrypting the private material of the child key. This is why we would have to create a TPM session of policy type to satisfy the policy we set here. Once we have the TPM2 session of policy type, we specify TPM2 policy secret on the owner hierarchy. And once this is extended in the policy session, we will have the digest to satisfy the next operation, which is TPM2 create for a child key using our primary key with the session. And then at the very end here comes the difference. With the -P, we provide our policy session that will satisfy the extended authorization. This is just a summary of all TPM22's commands that we used to generate a primary key object using a policy. And when creating a child key, we would have to satisfy that primary key policy using a policy session. This slide I prepared as an overview of what we learned in this lecture. It is important to remember that a trial session is used to create a policy, and a policy session is the only way to satisfy a policy. Once we apply the policy, we also need to consider in which situations we would be asked to satisfy it. This is why we had the two examples with applying the policy on a child key and applying the policy on a primary key. Both use cases have different advantages, so you have to decide at which stage and what TPM 2.0 policy would work best for you.